Hello, I'm Neeraj. Today I will explain the concept of LangGraph. So why we need such kind of tools? Actually, what happens several times, chains or linear systems fails to serve our purpose. So let us try to understand through a simple example, very simple example. Suppose you are trying to develop a smart writer. So the task of a smart writer is to write an essay in 100 words. So there will be two things when you design such systems. There will be a writer, there will be a grader. So writer will write and grader will grade. So it will write. And then grader finds that the output is 120 words. It checks that whether the output is in 100 word or not. Then it says that output doesn't meet the requirement. System aborted. Now what you will do? You will restart the system again from scratch and repeat it multiple times. So after some iterations, by manual involvement you will get some answer. So this is not the correct way. And this is the problem with such kind of chain based system. It cannot pack and check the issues and correct it. So here first things are no control loops. But here we can, if we apply the control loop or make it little non-linear, then what kind of control loop we can say that we will apply two control loop, yes and no. Means if it is a 100 word, then give the output, and if it is not in 100 word, write it again. So this is the first solution. We can say that after some loop is equal to 2 or 3, just try for 2 or 3 loops and then generate the answer. So most probably you will get the answer. So this is the first solution. Now system is still not so simple. Now suppose your scenario is little complex. Now you are trying to develop a smart writer and you have given the task like write an essay on a political event, and condition is like the length should be 100 words. Another condition is like if the font is F1, then color should be blue. If the font is F2, then color should be red, and name of the city should be there where the main events happen. So many things are there. Now how you will design such complex scenario? So let us start. So first of all, you will take a writer, which is your smart writer, which can write the essay on a political event by doing your task, like include the city, follow your every instructions like in 100 words. So you can give the prompts like write an essay with the length prompt with output length should be in 100 words. If you use the font F1, make the color blue. Use font F2, then make the color red. Include the city of main events. So many instructions you have provided to them. Now there will be a grader 1 and there is a grader 2. So what? Once the writer write, it maintain a notebook because a lot of things are there. So there will be a shared notebook. So in that shared notebook, it will write that okay, length is 100. It says that what font is used, font F1. What color is used, it says that okay, blue. City name is there or not, didn't find any city name. So it write everything and pass it, and then it checks. The first grader will check just length and font and color. So it checks that okay, length is 100, correct, font is F1, correct, color is blue, correct. So everything is correct, yes, pass it to grader 2. Now the grader will check whether the city name is there or not. Find that there is no city name, means something wrong happened. It will say that okay, write it again. But suppose if city name is there, then what will happen? It says that okay, city name is there and output will be generated. Here also there will be two conditions. First is like if anything is not matching like length, font and color, then it will say that okay. For example, if color is not matching, it says that okay, color is not matching and then pass it to writer. Here it says that city is not present, pass it through the writer. So there are two conditional things. So this is little more complex. So here one additional things are there. All the nodes are playing some task. First we'll start the application, then writer node will write something, then grader 1 node will check the length, font and color, grader 2 will check the city name present or not, and there are ages. So how the ages are there? This age one sequential age means direct age. Like once they generated all the outcomes, it noted the information in the shared notebook and pass it through the next node. Then there is a grader. It grader contains some conditional ages. So two conditional ages are there, yes and no. So if something is not present, then no. If present, everything is present, then yes. Then it passes through grader 2. Grader if the yes condition is yes. Similarly, grader 2 also has two conditional nodes, no and yes, and then final outputs are generated. And grader 1 and grader 2 checks the informations from this shared place or shared notebook, shared dictionary, anything you can develop. So now you have understand that what is the LangGraph. So this is an example of very basic LangGraph where you can propagate through nodes, you can apply conditional things, you can handle the scenario where loops are present. You can also handle the scenarios where multiple branches are present or some complex graph type of examples are present like this. So in the Lang graph, you can solve or divide your problems into graph type of complex structure. You can apply loop, you can apply conditional things which are not present in other sequential models. And you have identified that you meet three things. First, node, state, and ages. What is the state and what you are getting through the state? So, state are shared notebook, shared dictionary, single source of truth, you can say. And any number of node can share the state. Maybe one node or maybe multiple node can share the state, same state. Or there may be multiple states connected to the share, connected to the same state. So as complex you will go, you will find this, all those things. Now, what state stores? User questions, retrieved context, immediate reasoning, final answer. For example, here the state is stored length, font, color, city name, like that. It can store the question also. Now, the next thing is why state matters. Debuggable. So, like you debug the program, you can check that where the errors happen, and based on that, you can take your decisions. So that's why it is debuggable. Deterministic. You have seen that everything is straightforward. So that's why it is determined. And it is replayable. Replayable means you can run and update the states multiple times and you can compare that what was the information in the previous state, what is the information in the next stage, you can compare. So that's why it is replayable. And through these comparisons, in the complex scenarios, you can handle the issues also. So states are very important to handle the programmatic issues, logical issues, or a lot of things. From the state entry, you can get the entire information that how the system is working and where the things are going wrong. Now the next thing is node, because three components are there in LangGraph. So node, what is the node? So actually node is just like a graph node. It is a container. So this container may contains a Python function. Even it can says it can store Python print function also. It can be an LLM agent, or it can be multiple agents. One single agents are also possible, multiple agents are also possible. Another thing is like it can contain some calling functions also. Like suppose you are trying to develop some functions which require uh, net surfing, then there will be some API inside the node API function that will go through the particular URL and search the required informations by you. It can be LLM call, tool call, validator. Yeah, validator also, because here we have identified used node as a grader. So similarly, it can be a validator. So what it does? So what is the functionalities of node? So like here, if you go through the writer node, then it was writing information, grader 1 was reading information, grader 2 was reading information from the shared node and validating. So G1 and G2 is validating, W is just writing. So it can do read state, write partial state, so it can do both operations. Now let us come to one more scenario, like if you say that in a node there will be multiple LLM agents, then what will happen? In that scenario, what will happen? Generally, LLM agents take some time. Suppose it takes 1 second to answer anything or think and answer anything. And suppose we have 5 such kind of agents. So there will be at least 5 seconds, wastage of 5 seconds. Another thing is like LLM agents are generally talking to each other in giving some answers. So in that case, there will be some, suppose 2 3 seconds, another 2 3 seconds. They will share some memory. That node will share some memory and store information. So that reading writing will take another. So in that case, if you use multiple LLM agents inside the node, which is possible, but it may be costly. So please wisely design your system in such scenario. So what are the ages? So ages you already explored a lot. So ages can be linear, conditional and looping. So here in the first example, it was a linear. After writing, it sends the commands to grader 1, grader 2, grader 1. But here it is conditional. It checks the conditions yes and no and then creates a loop. So that is both is possible here. And why it is important? Because it prevents the hallucinations, enable rewrites and enable validations. So through the ages you can design anything. So what they do, it routes the executions, enforce the logic. So anything that is written in the notebook, shared notebook.